So I'm Josh Triplett. I'm on Twitter as Josh_Triplett. Please don't all run off to Twitter simultaneously and disappear from the in-person event. I'm a member of the language, library, and cargo teams, which I really love working with. And Rust, I care about a great deal as a technology. I think it's absolutely incredible, does a lot of things many other things don't. However, I care about Rust even more in terms of the processes used to develop it, and in terms of the people that make up the project. And so that's definitely an ascending order of importance. So I want to give a little bit of history for myself. I was at the first RustConf in 2016 and gave a talk, RFC in order to form a more perfect union, about adding C-style unions to Rust to support building virtual machines based on Linux and dev.kvm. But as well as being a technology talk, this was really fundamentally a process talk about adding things to the language using the RFC process. So I'm really honored and proud to go from presenting about unions at the first RustConf to presenting the state of the union at the current RustConf. So by way of how Rust has evolved over time, I want to mention my own first Rust project called Git Series. Git Series was trying to track the history of history, versioning a patch series. And I wanted to build this on libgit2 because I didn't want to reinvent Git myself. So I started looking at the documentation of this and saw things like, this returns a tree entry that's owned by the tree. This returns a tree entry owned by the user and must be freed explicitly. I saw lots of things like this, and my thought is, do I really want to write this in C? And the other thing I kept seeing over and over was things like is owned by, ownership. Where have I heard that before? So I'd been hearing about this new Rust thing and following all of the blogs on Planet Mozilla and other places, and I saw that it had just hit Rust 1.0, which was really exciting. It was stable, no more breaking changes, no more runtime, which is incredibly exciting, really differentiating, no more pointer sigils, it doesn't look like Perl anymore. And most importantly for my purposes, there was this great library, Git2RS, that Alex Crichton wrote that bound to all of the libgit2 calls and took care of all of those lifetime issues for me. So I learned Rust in the course of writing Git Series, and one of the biggest things I ran into was error handling issues. That was my Rust is hard to learn moment, was dealing with error handling. So Rust was a really different language back then. Question mark didn't actually exist yet as an operator. Kind of hard to imagine now, but that was not introduced till Rust 1.18 in November 2016. That was really quite a contentious change, and I was doing this work in early 2016. So at the time, there was still the try macro, which tended to pile up on the left rather than being postfix, but hey, if at first you don't succeed. So error handling was complicated for a number of reasons, but most of all, you had to build an error handling type, something to be the E in the result of type and error that could hold any error you might produce, whether that was an error from Git2, an IO error reading and writing a file, a UTF-8 error dealing with character sets, and it had a whole stack of requirements that I won't go into, but in general, I have to write this by hand. I have to write out a manual error enum, and I have to add to it whenever I try a new error type that I haven't used before. Well, fortunately, there were already libraries to deal with this. There was a library called Quick Error that provided a macro looking a lot like an enum. It implemented all the traits you need to make an error, and you just add a new variant for each error, and it was fairly easy to do, a couple lines of code. It's actually almost as old as Rust 1.0. It was released right around the same time. So people looked at this, lots of people used it, it was very popular. They're like, this is much better than what came before. Clearly everyone should use this. Why isn't something like this in the standard library? So you may be able to see where I'm going with this, and I want to go through some of the history of error handling by way of how Rust and the ecosystem evolved together. A bit of a disclaimer on that, this is very much a partial history. There are far more libraries than I have time to cover. I'm omitting a lot of unimportant details. And really, many, many people deserve credit for all the changes along the way, and I can't possibly cover them all. But the next library that I had experience with that lots of people used was called Error Chain. Its big innovation was, hey, let's preserve the error that caused an error. You failed to open this file, let's capture I failed to open this data file, and the reason for that was a permission error, or the file doesn't exist, or cosmic ray. And this was a really popular library, made it much easier to debug where an error came from. There was a blog post about it, how to start a new Rust project right with error chain. And this library was much better than what came before. Clearly everybody should use this. Why wasn't something like this in the standard library? So the next major development after that was a library called Failure, which was much simpler to use. It had a new, simpler version of the error trait called fail. It had a proc macro derived to create your enum, which means you could use Rust actual syntax to write your enum. Also provided a catch-all type for when you don't really care what kind of error it was, you just need to do like simple command line error handling. And it made it really easy to write your error messages for each variant because it had kind of a display derive as well. So this was much better than what came before. Clearly everybody should use this. Why wasn't Failure in the standard library? Well, at this point we did start to make some changes to the standard library. We simplified the error trait. You no longer had to implement a few methods in order to write error. You just had to say this type is an error and implement a few other things. We built in support for error causes and chaining, the same thing that error chain created and Failure continued with. And there are some new types that came up at that point, new crates that came up at that point to take advantage of those changes. So anyhow was the new catch-all error type, and it was built on those same standard library changes. And then this error was for when you wanted a derive to have individual enum types rather than a catch-all, and it was just as lightweight as implementing it all yourself. And we made a few more language changes at this point. We added support for returning a result from your main function, and you didn't have to write any error catching boilerplate anymore. But now we're doing actual output to display the error and report the error. So what should the reported error look like? There's lots of opinions on user experience. Should this be for quick and dirty programs, or is this something everyone should use? So at that point, error, written by Jane, currently on the library team, Jane's error library, Jane Error. But it gives full control over error reporting, over what information you collect if you want to get a backtrace or a span trace, all sorts of other useful things. And we're making more changes to the standard library further to work well with things like this. We're adding a provider API that lets you attach arbitrary information to an error, like a span trace or a backtrace or similar. And we're finally moving the error trait to core. I'm expecting that to go in literally any day now. And we're going to make more changes in the future. We'll likely add a standard catch-all type similar to anyhow or error. We'll likely add a standard derive error or derive display. But the whole time we were evolving these libraries and adding a few more things, people continued to ask, well, why can't there be one standard way to do this? Why are there so many error handling libraries? What would have happened really early on if we had merged something like quick error or error chain and not had time for them to evolve and bake and improve further? So obviously the lesson for this is that we should wait a long time and make sure everything is completely settled before we add anything to Rust, right? Well, along the way though, we made a lot of incremental steps. We added changes to the library, changes to the language to make Rust work better with those various error handling libraries. We didn't just wait for all the dust to settle. So the key thing is that Rust and the ecosystem evolve together. This is constantly true, and it's a constant cycle. This has been true for many other things. This was true for async await, where it was a major use case for Rust users. People wanted to experiment throughout the ecosystem. And this was so much easier to use when you had native syntax for it rather than writing it all with macros or similar. So async await itself, the syntax, was stabilized in 2019 in Rust 139. Async library standardization is still an ongoing process that I'm very excited about, but it's still continuing today. And part of why that's important, well, it would be nice if we had one set of traits to write async rather than one for every ecosystem. But if we standardized async right a while ago, it would look more like this, with things like pin and context and poll that the vast majority of people should never have to deal with. And the async write trait we hope to have is something more like an async fun that looks exactly like the regular write call and isn't any more complicated than the regular write call. So I'm not going to go into great detail on async. For more on that, see Nick's talk later in the day. But there are a lot of other libraries, smaller ones as well, where we picked up changes from the ecosystem and said, hey, lots of people are going to want this, let's put it in the library. There was a library called Boolinator that provided functions for working with bool types and generating options, generating other types of things. And we added functions to bool to help you generate the option type conveniently. We saw that lots of people were using the num CPUs crate to find out how much parallelism they should have, how many threads should be in your thread pool, and we added stood thread available parallelism to do the same thing. So we see things that are widely used and really have one correct way to do them. There's no reason to have 20 implementations, so we add them to the standard library. And another that I'm incredibly excited about is the I/O safety work, which is stabilizing this week, I believe. So, or shipping in the version coming out later this week. So this brings safe ownership, safe borrowing to a native OS resource, file descriptors and handles, that previously needed unsafe. And I'm expecting this to be very much a new foundation for the ecosystem where libraries rework to use these new types rather than older ones. But this is a continuous cycle where we have a full foundation of the Rust language, libraries, and tooling. We have established crates that build on those. We have more experimental crates that build on the established crates and try interesting new things. And we have applications which consume any of those and try to provide useful functionality to the user. And all of these feed into each other in a very continuous cycle. We have experimentation in applications in more experimental crates to come up with exciting new ways to do things, and the best of those find their way into standardization in the Rust language, in the Rust standard library, in more established crates, and this is a continuous cycle. So lots of things can happen if you stabilize too quickly. You could end up with a skyscraper with exposed girders in the foundation. You end up with unfixable problems. You're trapped by your stability guarantees. And this can really stifle ongoing innovation on an API itself. Oh, we've now standardized a thing, so there's no point in continuing to experiment and make it better because here's the standard thing. So we don't want to do it too quickly, but if we stabilize too slowly, then we don't have any foundation at all. There's too much uncertainty out there, and this stifles innovation above the API. Oh, I want to build on async, but there's too many different libraries. Or I want to build on this technology, but there's too many variations. I'll wait for the dust to settle. So what can we learn from this? Well, one big question we continuously ask ourselves is, when do we start standardizing things? We have to balance between experimentation on an API, when we're still improving and cycling on that, with experimentation atop an API, which really wants to have a stable foundation to build on. And there's no one right answer for this. This is a continuous process and continuous refinement. We've also learned to be careful of the second system effect, where, oh, we're going to make this perfect the second time around. Let's redesign this and put it in the standard library at the same time. That's never a good idea. So redesigns are something we always want to prototype outside the standard library and then fold in. Even if we fold them in fairly quickly because we know we're looking to, we want to do the experiment, try it out, and then pull it in. We also hope, honestly, to make standard a little bit less special as a central place in the ecosystem. It's still the standard library, but we could use fewer nightly features. We could standardize a lot of the things that only the standard library uses and stabilize them so that other libraries can do some of the same tricks we do. And we're also hoping to avoid breakage when we standardize things. We've taken things like itertools intersperse, stabilized it as iterator intersperse, and we ran into a lot of conflicts where somebody using itertools would now get compilation errors. This was especially bad when the name was still unstable, so it was, you've got a name conflict, you should be using this thing. Oh, this thing's nightly only. This was kind of an unavoidable error. And we're improving name resolution in some ways to try to avoid this, to try to steer towards, if you're using itertools, you must have wanted to use itertools. And in the other direction, we're thinking of adding things like config accessible to let things like itertools say, well, I'm providing intersperse, but only if the standard library doesn't. And in general, we have incredible stability guarantees. It's really important that we promise that that brand new Rust compilers will compile all of your old code and never break anything. But we are also looking to support additions for the standard library. Additions have been a great way to evolve the language without breaking changes for existing code, and the library has historically not been able to make use of that, and we're hoping to change that in the future. So I want to quote a blog post that Jane wrote and lots of people contributed to that was all about how we develop Rust and the process for improving Rust. We don't think it's sufficient to build robust systems by only including the people who don't make mistakes, because there aren't any of those. We think it's better to provide tooling and process to catch and prevent those mistakes. And this is exactly the kind of thing we're doing to make sure we don't lock ourselves into, oops, we promised that stability guarantee forever and we can never improve it. So as a result of all this evolution, a lot of people start asking questions like, well, when will Rust stop changing? When will Rust be done? And from inside the ecosystem, if you're already using Rust, this can sound a lot like, well, when will Rust stop evolving with its ecosystem? When will Rust stop listening to its users? When will Rust start dying? Well, we're not planning on dying anytime soon. But people who are asking this are really asking for a stable foundation to build atop. They're in that layer of, well, the layer underneath me isn't a firm enough foundation. When will that layer stop changing? And so one of the things we want to improve on, but that we already somewhat do, we can evolve and still provide a stable foundation underneath. We already don't break stable Rust code, and supporting new use cases does not mean we're breaking the existing ones, but it does mean that there's some more to learn. So I talked about how Rust and the ecosystem evolved together, but I also said that I care about technology and process and people in ascending order of importance. So I also want to talk about how Rust and the community evolved together. Well, our processes are in many ways an API of the Rust project. They don't have quite the same stability guarantees. It's inconvenient when they change, but they're not immutable. So I want to talk about a few of those processes and the current state of them. First of all, the initiative process. A number of teams have been experimenting with a new process for proposing changes that was supposed to be lightweight, unlock experimentation, make it easier to contribute. And the quick update is, unlocking experimentation, check, that worked really well. Simplifying contribution, not so much. We ended up making it a little more complicated to contribute because there are more entry points and people weren't quite sure which way they should be contributing. So expect some further iteration and simplification on this process to make it more obvious, here's your one-stop shop for, I want to contribute to Rust, what kind of issue do I need to file, where do I file it, etc. I want to talk briefly about the target tier policy. This is the policy we put out some time ago for how we support different targets. This is tier 1, we all support it together. This is tier 3, it's supported by its users. And it talks all about how we support those targets, who supports them, and most importantly, who does which part of the work. And this is going to be a recurring theme in a lot of our processes of many use cases should be well supported. Some of them should be supported communally by the entire ecosystem. Some of them should be supported by the people who have those use cases. And finding that balance is a challenge and a continuous discussion. We've talked about having process for community projects, easier ways of like, we need a successor for the working group, project group, et cetera model, and that's still somewhat under evolution. And a very brief update on Rust governance. So many of you may have heard that we've had some issues and improvements to make with Rust governance lately. I'm not going to go into great detail on those, but effectively, we discovered undefined behavior in some of our processes. Oops. And we put together a bit of interim governance to try to work our way through those, but as we worked on that, we very much wanted to make it clear that we were not looking to just rotate who was in the structures. We were looking to build new structures that got rid of that undefined behavior and improved how we run Rust and what processes we use all the way up. We also want to avoid the second system effect, remembering that same lesson, so we don't think we're going to get it perfect the first time, which means one of our most important goals is to have processes to evolve smoothly over time and never have Rust governance process 2.0 and a new Rust governance crisis in that way. One other experiment we're doing is that we have the RustConf, PostConf, Unconf tomorrow, which many of you may have already registered for. It's a new experiment to see how an unconference would go attached to the conference, so looking forward to seeing many of you tomorrow. I also want to talk briefly about the process by which we support Rust contributors. You're going to hear talks from many, many people today. They are wonderful speakers with amazing topics to talk about, and we have explicitly asked people and normalized the idea of asking for support if they're looking for it. And people need support in a variety of different forms, but they're not going to be able to develop Rust without it. And this applies outside of RustConf as well. Watch for people who are seeking support in areas you care about. Watch for people who are seeking support in areas Rust desperately needs. And if you're in a position to do so, then see if there's some way that you can help. And that doesn't just mean helping with code. So that can come in a lot of different forms. Some people are looking for employment. Some of the people today may be looking for a job. Some of them may be looking for a contract. Some of them may be providing services or looking for some kind of services. Some of them may be looking for sponsorship. And so I want to encourage you to support the people who are working on Rust to make Rust possible. And if you see people asking for support, saying, hey, I work for this, I'm looking for a new role, I'm looking for sponsorship, that's normal, that's expected, that's not something we should look down on people for, that's something we should encourage. Everybody's looking for support. So, thank you. Thank you, I really appreciate that. Yeah, when did it become less kosher to explicitly talk about how we support the work that gets done? But being an example of that myself, I am working on build systems with a startup called Build It. I do contracting with FutureWay, which I'm really happy working with. And I do GitHub sponsors, which I'm really grateful to all of these people sponsoring my work on Rust, including Solana and Embark Studios, and I really appreciate that. And I want to thank you. Please enjoy the conference. Please enjoy all of the other amazing speakers, all of the hallway conversations, and all of the wonderful people here and online. Thank you very much. Please enjoy.
All right. Hello, RustConf. It's so great to see some of you in person this year. My name is Tyler Mandry, and I've been working in the Rust project since 2018. Today I lead the async working group, and I'm also director on the foundation board. 2022 has been a very good year for Rust. This year, for the first time ever, we were voted the #1 most wanted language in the Stack Overflow survey. Now, you may recall being voted most loved language in the past, and we got that again, but this is the first time we had more people wanting to use Rust than any other language. This year, of the people who responded to the Stack Overflow survey, almost 1 in 4 said they wanted to use Rust next year, and almost 1 in 10 are using it today. Another survey from a firm called Slashdata found that Rust is used by well over 2 million developers today. And that's tripled in the past 2 years, which makes Rust the fastest growing language by far. These are big numbers. I mean, people are really starting to notice. I actually complain about Rust all the time. But the point is, for a language to see this much success as quickly as Rust has is an incredibly rare thing. And today I want to talk about how we got here, the ingredients of Rust success, what I call its soul, and how we can keep that success going forward as a project by scaling those ingredients along with Rust's growth. And finally, we're going to cover how you can embody and affirm them yourself. There's an old saying you may have heard that says, if you want to go fast, go alone. But if you want to go far, go together. Now, this quote predates computers, but it really embodies the dream of open source, and in particular, Rust's commitment to those ideals. You see, Rust has gone far, and in fact, we've been talking about ideas like this for years on our blogs, through the community, and in places like RustConf Keynotes. And in particular, there are two themes you see in these discussions that characterize how the Rust project and the ecosystem around it operate in a unique way. These themes are key to Rust's success. And the first theme is openness. Now, of course, Rust is an open source project. That's not what I'm talking about. Openness is about being open to ideas and perspectives other than your own. Rust was built with the help of grizzled C systems programmers and with the help of Ruby and Python developers who wanted to speed up their web apps. And those groups didn't really overlap that much before. The language team has a saying that I love. They say, treasure dissent. And treasure it not because arguing is fun, but because disagreement leads to insight. When we consider another use case or background, it tells us something about our own perspective and how that colors the work that we've done. And just as importantly, it allows us to come up with better solutions than any of us would have individually. There are countless examples of this happening in the Rust project, from design of the module system to async, all the way back to the naming of integer types. Now, it's a very natural human tendency when our ideas are challenged to want to dig in and defend them. After all, there's a reason we chose this spot right here. But the spirit of openness is to resist that urge and not only stop digging in, but to take a stance of curiosity and humility that dives into differences and learns from them instead of minimizing them. Because openness is not about winning, it's about changing minds and allowing others to change yours. When you have a shared inspiration and you're moving in sync, building something together becomes much easier. Now, let's be real. No one is unlimited in their capacity to do this. You can't build a language for everyone, and eventually projects have to make decisions. But because we practice this openness, those decisions tend to be made with a much better understanding of the trade-offs involved and the principles behind each option. Now, if openness is about how we listen to other perspectives, the other theme, inclusion, is about how we seek them out in the first place. Inclusion is about seeking out different backgrounds and perspectives and making space for them in all parts of the development process. Yes, this is the right thing to do. We should give people access to the same opportunities that we have. And it also leads to better outcomes. Now, I want to be honest with you. The truth is, this is the most difficult challenge I think Rust faces, or that it's ever faced. We all have to choose how we spend our time, and a lot of the excitement that people get from working in open source is in those technical problems. So when we're confronted with social problems, it's much easier to say, sorry, you're just too different. I can't pay attention to you right now. But Rust's inclusion is its strength. Its ability to bring together seasoned and novice systems programmers, both imperative and hardcore functional programmers, and enable them to build things at a level of expressiveness and safety that we've never had available before. Inclusion lies at the heart of that. So inclusion is hard, but Rust has chosen this path time and time again through things like enforcing a code of conduct and creating the RFC process and iterating on that. And it's better for it. So openness and inclusion, these two sides of the same coin, these are the soul of Rust. And when you build something that's meant to go as far as Rust has, it's always a collaborative process. And the fact that Rust has this critical mass of people that are willing to think and behave in these terms, it's not just some idiosyncrasy. It's a strategic advantage for Rust. And it's the thing that built it into the language that it is today. In fact, some of our top contributors in the project are here today because of it. So these values are what make Rust not just a digital technology, but a social one. And this doesn't stop at the development of the language or the tooling. It's very much a part of the whole ecosystem that's built around the language and the culture that it inherits. Now, we've seen how big that ecosystem has grown. To bring it back to the language, the Rust team has also grown quite a bit since that keynote from 4 years ago. The number of people in our team's repo has quadrupled. So I think it's time to check in and ask, hey, Rust, how are you doing? Because if this is the soul of Rust, it's important that we pay attention to it and make sure that we're carrying it through to the next chapter, and also that it doesn't get swallowed by a sandworm. Now, there's good news. It's easy to find examples of these values echoing throughout the project today. If you ask around, you'll hear project members say things like, we document, we mentor, we tag issues for new contributors. The contributors will say things like the reviewers are kind and you can feel the good intentions from a mile away. On the other hand, if you dig in, it's also easy to find examples where things break down. You hear things like things are slow moving, no one has reviewed my pull request, or maybe it's just been ignored altogether. And in fact, if you look at the latest Rust survey and dig into the numbers a bit, you'll find that 30% of people who report trying to contribute to Rust never succeeded. And around 8% of people never felt welcome to participate in the first place. Now, I'm not saying Rust is doing a horrible job here. I think we're doing very well in some areas, but that doesn't change the fact that we could be doing better in others. So what can Rust, the project, do? The title of that talk from 4 years ago was People Systems Programming. It was about this idea that all technology, including Rust, is made up of people, and open source projects are a system of people. But programming is what we call it when you're kind of standing up a prototype and getting something to work in the first place. And we have a different word for when you have something working and now you're building it to scale. That's engineering. So let's build on the ideas from that talk and from others and talk about how we go from people systems programming to people systems engineering. Because Rust has reached a scale where thinking about it in these ways makes sense. Now, when you engineer a system to be reliable at scale, one of the first things you do might be to set up monitoring. This is a graph of response times at different percentiles for a web service. If you talk to someone who works on a system like this, they might tell you that the most important line is the top one, the 99th percentile, meaning the worst 1% of response times. They'll tell you to focus on what's happening in these requests because that's where you're going to learn the most. Those responses are where the really big problems live. And sometimes you study one and you find there's nothing you can do. Some things are completely out of your control. But other times you find a problem in your system that under higher loads might bring down your whole service if you don't fix it. So what if we could take this idea and apply it to people? Specifically, what if we study our successes and failures to include new perspectives and pay close attention to those failures, because that's where we learn the most. That's where we'll find the biggest cracks in the system. In this metaphor, the higher the percentile, the fewer people it captures, but generally the worse experiences people are having. And as we saw, we had 30% of people trying and failing to contribute to Rust. That's around the 70th percentile, and 8%, that's around the 90th percentile, is the person who doesn't feel welcome in the first place. And these are just the people we're reaching with the Rust survey today. It's not at all representative of what we'd like the project to look like 5 years from now. We want to see more Blacks, Indigenous, people of color, women, non-binary, people in time zones that aren't the US or Europe, and people in roles other than engineering, because contributing to Rust is not all about writing code. And that's not an exhaustive list by any means. These groups that don't have good representation in the project today, they have the biggest headwinds to getting involved in the first place. And that's why we focus on the 1% of people who have the most difficult time. We want to see that 1% become 2% and then 5%, maybe even 10%. So people systems engineering consists of seeking out underrepresented groups and perspectives that we'd like to include, paying attention to our failures to include them, and seeking to understand those, and finally practicing openness and curiosity. Now, I want to emphasize that this is for everyone listening to this talk. If you're part of the Rust community, it applies to you. There's no other way to scale this. Like, as the number of Rust users and their perspective goes up, so must the number of open and curious people who interact with them and build a shared understanding of common problems. The core language team is like 5 people. They can't do it all by themselves. And these values are aspirational. Rust is nowhere near perfect, and in fact, there are some common pitfalls that we need to watch out for. So first, any group of people will tend to sort itself into new power structures over time. This is human nature. It just happens. But without documentation, it makes the organization completely opaque and unapproachable from the outside. So we need to watch for when this is happening and periodically make sure that the power structures and processes that we document match what happens in reality. Second, we've all been taught from a young age to hide our work until it's finished and perfect and ready to turn in. But no part of Rust is a solo act. This is particularly important for anyone who's on a team or a leadership position of any kind, because people tend to index on your thinking. So you need to document that in a public place. Now, this can be hard because putting something out there means opening it up to criticism. That's criticism that you might not be ready for emotionally or intellectually yet. And you're certainly not required to respond to all of it. But on the flip side, if you only share your thinking with a small group of people that you trust, you're creating a privileged class within the project. Now, I'm not saying everyone has to be a part of every conversation. Obviously, that's not possible. But you never know when the person with exactly the right experience for this moment is around the corner. And they need to be able to follow along and join in when the time is right. Third, when you feel overwhelmed, and this happens a lot in open source, it's common to prioritize based on your familiarity with the person. Anecdotally, I can say that the people whose pull requests sit unreviewed tend to be people who aren't already known by project members. Now, if you've committed to mentoring someone or reviewing something they write, obviously you should follow through, but beyond that, don't always prioritize your friends or the people you know. It'll only reinforce the existing in-group, out-group dynamics and ultimately hinder Rust's growth. Now, I've been working in the project and I'm personally guilty of every single one of these. So to reiterate, these are all things that the Rust project can get better at, and we want the help of anyone who's willing to contribute to them through tooling, metrics, or other ideas. Finally, we've been talking a lot about what the project can do, but now I want to talk about what to expect when you're expecting to contribute to Rust. If you or your company participate in the development of Rust, you're already gaining all the benefits of a healthy open source project. I think we all sort of understand this intuitively. It's supposed to be this commons where something useful gets built and given away. And that leads to more people coming along and improving the useful thing. And then let's say you're a company of some kind, you can come along and push on the features that matter the most to you, while knowing that other important things are getting done without you having to know about them. And by the way, I tried to address this slide up a bit, but I do want to make sure that I'm engaging the more corporate members of the audience. You're welcome. Now, I do want to talk about how to contribute to Rust as a company. This is becoming a critical part of how Rust is developed, and it's also a great case study of how to apply these values in practice. Now, if you've been around open source for a while, you've definitely seen this breakdown, this open source ideal breakdown in other projects. You see features land without any documentation. You see complexity and tech debt accumulate over time without clear owners. You sometimes see reviewers who become kind of zealous gatekeepers, and eventually it becomes so hard to contribute that people kind of invent their own workarounds instead of actually fixing problems upstream. In extreme cases, they will fork the project and maintain a fork. This is all very painful. So if you want to participate in open source and really make the open source dream a reality, you need to support the context that makes your participation possible. And that's the project. I have two ideas for you to consider. First, when you're contributing to open source, it's common to think of your contribution as simple as design, implement, hopefully with documentation, and then land. But for the project to stay healthy, someone needs to drive that feature to stabilization and continue maintaining it over time, answering questions and paying down tech debt. So make sure you're committed for the full life cycle of a feature and include each stage in your planning. But it doesn't stop there. There's a cost for the project, meaning the Rust project, to accept this contribution as well. Someone in the project needs to consult on the design and agree it's something we want in the first place. They need to review the implementation. They need to manage the release and testing processes, and they need to triage incoming bugs. If you work on Rust for a company, I invite you to think deeply about these costs and how your company is contributing them back. The second thing I want you to recognize is that the Rust project has its own culture and values. They aren't the same as your company, and you need to uphold them when you engage with the project. They are a part of what makes Rust good technology. And now, I work on a team for a company that uses Rust, and I know many other project members do as well, and know if you're in that situation, you bring a valuable perspective to the project, and we want that perspective. But it can be tempting to use your position as a source of authority to make other people go away. This runs counter to all the values that we've been talking about. So your perspective needs to be delivered with a little bit of humility and introspection. And also remember that your counterparts in a discussion might not be on the clock. They could be volunteers with less time to commit to a discussion than you have. And that's not a license to ignore them. If anything, it means you have a greater responsibility to practice openness and curiosity. Try to pull out the valuable parts of their perspective. Finally, if you're a manager, recognize that this is a skill that not everyone is willing or able to do well. In fact, it can be quite difficult. But working in a project like Rust requires practicing these qualities of openness, curiosity, tact, because influence doesn't have anything to do with their seniority in your company. It has everything to do with their ideas and their reputation. And the reputation of someone who's working for you becomes your reputation. So it's crucial that you recognize this as a skill in your employees or contractors and reward it. So to bring it all together, Rust owes its success to these core values of openness and inclusion. The project will stay healthy by building scalable structures that affirm them over time. And you can help by understanding and affirming them yourself. Now, before I close, I want to say that, as Josh mentioned, a number of our speakers today are looking for sponsorship. Now, I've been speaking for myself, but I do work for Google on the Fuchsia team, and I'm lucky enough to do this work as part of my job, so I don't need sponsorship of any kind, but do please keep your eye out for people who are seeking that sponsorship or other support, and consider supporting one of them. If you have the means, it's one way that you can support some of the awesome people who are working on Rust. Thank you all for listening, and now I'm going to hand it back over to Nell.